transformations we've studied so far this year. These came in, we started them in Unit 1. We did a little bit in Unit 2, I believe. Transformations, we have some that are rigid transformations, which means they do not change the shape or the size of the shape. And those are translations, rotations, and reflections. And then we have some that are not rigid that may change either the shape or the size of the shape. You may go to a similar shape, which means it's the same exact shape, just different size. It has the same proportions with each side. And that one would be a dilation. You either make it larger or smaller. Remember, if you multiply by a number one bigger than 1, it's larger dilation, and if it's less than 1, it's smaller. So it's not always just bigger. And then we have some that is a horizontal or vertical stretch, and that is where we multiply, or we like stretch it like side to side or up and down, but not both. Or you could do both, but not at the same rate. And we're just going to have a little review on this. And we're going to do it in the Cartesian plane. And I'm just going to draw a quick little triangle here. All right, and if I said that I want to move this triangle plus 3 and y minus 2, that means I'm going to move it right 3, and this negative 2 means down 2. So I'm going to go 1, 2, 3, and then 1, 2. This is this point. So if this were A, this would be A prime. I'm going to move those out of the way so it doesn't affect us. And then, so here's B. I'm going to move it right 3, 1, 2, 3, and 1 down 2. And here is B prime. And if this were C, I'd go 1, 2, 3, 1, 2, and this would be C prime. And that is a translation. Anytime we move it, that was ugly. Anytime we move it left or right or up or down, and we don't change its shape, it's simply just a translation. We're not rotating it, we're not reflecting it. It's still facing the same way, in the same position, just in a different spot on the graph. And that looks like this when you add or subtract from x or y. You can just add or subtract from only x or only y. It just moves it either horizontally or vertically, and not both ways. It's okay. It doesn't change the shape. So if we wanted to rotate, we'll just use this same one. If we are rotating a number, and we're only really dealing with 90 degrees rotation here, it's when you have x, y, that's your original, and then you want to rotate it. You are going to switch your x and y, and if this were negative, means it's counterclockwise. So you're going to take this, and if it doesn't tell you the center, I'm going to use this as the center. So 1, 2, 3, 4, negative 4, 1 is my center of rotation. And so I'm just going to flip this line 90 degrees. So this will now be A prime. And so this line now gets to go here, or, well, it may be easier to do AB, which will be here. and then connect these, and you get C stays on C. So that is a rotation. It doesn't change the size, so it is a rigid transformation. And then a reflection tells you if you want to reflect it in the y-axis, the x becomes negative, and although all of these x's in this shape are already negative, so a negative negative makes it positive, but you want to make, when you're writing your rule, you want your opposite coordinate to be negative. So if you want to reflect it in the y-axis, which is this axis, you want your x to be negative. And that just means reflect over your y-axis. So it takes 1, 2 to get to the y-axis. So it's going to take 1, 2 to get to A prime. And for C, it takes 1, 2, 3, 4. So 1, 2, 3, 4 to get to C prime. And B takes 1, 2. So 1, 2 to get to B prime. And now you have your reflection. If I wanted to reflect it over your x-axis, your y becomes negative, and you would just simply flip this over. It really is just, some of you like to say a flip. We're flipping it, but remember we have to preserve the distance away from our line of reflection. So it took 1 whole unit to get this shape to it, so it takes 1 whole unit to take it to its image. Remember, image is our second. It's our final thing. And then if we were doing a dilation, just going to show you what that means. So if here is my rule, I am going to multiply x and y by the same number. It has to be multiplied, and it has to be by the same number. So then that makes this larger. So instead of 2 here, we're going to have 4. And then everything is twice as large. Of course, you can multiply it by different numbers. It'll just change shape. And remember, if it were less than 1, then it's going to actually be smaller, and this would have looked like that because it would have been half as large. All right, and now we're going to do a horizontal stretch. I'm going to erase this part. And if that is where we multiply, I'm going to leave it there. We multiply either x or y by a different number than the other. If I just wanted to do just one of them, that is possible. So I'm only going to change it horizontally. So I'm doing 2, it'll be double. So since this is 2 already, it's going to be 4. And then this stays, my vertical stays the same. So it is a triangle, but is not proportionate. It just stretched it. If I wanted to do like the y by 2 and not the x, then that becomes a vertical stretch. It gets taller. It is still a triangle. It is still a right triangle, but is not proportionally correct.